All right, folks, today we're talking about even and odd functions. Even and odd functions have to do with the symmetry of the function. If it's even, it's going to be symmetric about the y-axis. If it's odd, it's going to be symmetric about the origin. If you have an even function, then f of negative x is going to equal f of x. Okay, let me just show you what I mean. If I have a parabola that has a vertex right on the y-axis, then every positive x value is going to have the same y coordinate as every negative x value. So they would line up horizontally like that. Also, that you can see the symmetry if I wrote, not because of the way I drew it, but if I rotate it around the y-axis, it will land on the other side. Okay, so you always have to look at the graph and what's happening when you plug in negative x. Okay, because an odd function, when you plug in negative x, is going to give you the negative of the original. Okay, and let me just show you by using a simple example. So here's a simple parabola. If I put in negative x, in for x in the function, and then I simplify. So negative x squared is negative x times negative x. Well, that ends up being positive x squared. Well, that's what I started with. If you get what you started with, then you know you've got an even function. If you get the opposite of what you started with, then you know you have an odd function. So let's do x cubed, because I know that's odd. If I plug in negative x in for the x there, now when I cube negative x, I still end up with a negative. In other words, I end up with the opposite. This negative here tells me I have the opposite of what I started with. I started with positive x cubed and I ended up with negative of x cubed. So that's an odd function. Anything else is going to be neither. Okay, so here's some even functions. Parabola, absolute value, cosine of x. Here's some odd functions. X cubed, a hyperbola, that's y equals 1 over x, or f of x equals 1 over x. And then a cube root function is the one in the middle there on the bottom. All right, so here's an example that you'll see in Delta Math. And then I have the solution written out here too, so you can see what they're going to be showing you. You have to plug in negative x, because you're going to be doing the algebra. So if I plug in negative x for every x, and basically I'm just rewriting what they did as the solution, but showing you that that's what you do. Then you do the algebra and simplify. So then you're going to get 9x, and you're going to get plus x to the 7th there. Well, can you see that that's actually the opposite of what I started with? Okay, so if I end up with 9x plus x to the 7th, since these two are negatives and these two are positives, what I resulted in, then I know I have an odd function. So if you get the opposite of what you started with, meaning the negative of what we started with, then it's odd. Okay, you could also have an example that's neither. So you're going to be determining if it's even, odd, or neither, and you're going to have to put in negative x to determine that. And then you have to do the algebra to simplify. So this is going to give me negative 6x to the 4th. I still have plus 1, and then I have plus x. Well, look at this. Everything's the same except this has a minus and this has a plus. So it's not the exact same thing as what I started with. It's not the negative of what I started with. So therefore, this is neither. And if you actually look at the graph, you can see with this particular graph, when you go to graph it, let me make sure. Yeah, the graph is a little bit skewed, so it's lopsided. So it's not symmetric about the y-axis. Okay, so the vertex has to be on the y-axis for a parabola to be an even function. Let's do another one. I'm going to put in negative x. All you're doing is substituting negative x for all the x's. And then you're doing the algebra and simplifying. So negative x times negative x times negative x is going to give me the negative of x cubed. And then here I have plus x. Huh. Let's see. If I factor out a negative, can I show you that I would get the negative of x cubed minus x? I started with x cubed minus x. If I factor out a negative, I get the negative. So this is odd. Okay, you can also look at the graph here. Let me plug it in quick so I know. The graph looks something like this. Ooh. So if you can see, if I rotate what's in the first quadrant all the way around to the third, I didn't draw it very well, but it would land on itself in the third quadrant. Here's another one. Plug in negative x. You get negative x squared plus 2 times negative x minus 3. I either have to get what I started with or the opposite of what I started with for it to be even or odd. So this is going to give me x squared. This is going to give me negative 2x, and this is going to give me minus 3. It's not what I started with, so I know it's not even. If I factor out a negative, is it the opposite? Nope, because here and here, so it's neither. And my guess is it's parabola, but it doesn't have a vertex right on the y-axis. All right, one more. F of negative x. Most functions actually are neither. They're not going to be symmetric about the origin or the y-axis. If I put in negative x, I get negative x cubed, and I get plus 5x. Well, that's not what I started with. Is it the opposite? Yes, it is. You can see what I have in parentheses exactly what I started with, and then I have a negative on the outside. So this tells me that that function is odd. All right, so plugging in negative x is what you have to do. If you get what you started with, then it's even. If you get the opposite of what you started with, then it's odd. If you get neither of those two things, it's neither. But also just look at the graph and see what if you can tell what's whether it's even, odd, or neither. So go to Delta Math, do the even and odd functions. What is this puzzle? Step Brothers. Reach out if you have questions.